Nice to see so many people here. I actually expected far less, because when you talk about, well, when you talk about money, developers are always interested, but when you talk about cost, everybody kind of leaves the room. So, and I'm actually not going to talk about money that I'm giving you, but about cost. So, and about microservices and AVS and continuous delivery and how we combine those. I am Tomas Riha. I work at Wireless Car, which is Volvo Group Telematics. It's our external brand. It's called Wireless Car. I'm very passionate about change. I've been working with automation for like 10 years in different levels. I'm an architect, developer, and yeah, change and automation is kind of what I do. My vision has been to build a continuous delivery implementation which is delivered as a service. So what my team does is that we build a kind of internal product which is our continuous delivery implementation. It has clear interfaces, and you pop stuff into Git and stuff falls out in Amazon. That's the entire idea of it. And you put your tests in a certain place and they run as the process executes. And our continuous delivery as a service, it's called Delivery Engine. And we're a small team of 4 people that build it in AVS and working as a DevOps team doing it. A little bit about Wireless Car. We've been doing Internet of Things for automotive before there was a word of Internet of Things. We've been doing it for like 15 years. Downside of having done stuff for quite a while is that you have a lot of legacy. So we have a lot of old systems running on old hardware and old infrastructure that we somehow want to renovate into a modern application. So we have a vision that we want to have a multi-tenant system, stop developing custom development for our customers, have a multi-tenant system that is based on microservices and ran as DevOps. That architecture we call Opus, and we're kind of rolling it out now for our customers. And this talk is about how we did that transformation into microservices, how stuff that we had to think about when it comes to cost and different culture aspects that we ran into when switching over from our legacy. We basically had this vision of microservices. Everybody knows it, so I'm not going to talk all that much about it, but small separate systems with their own life cycle. What was important for us was to have each microservice should have its own life cycle. That was basically the key for us, and that life cycle should be managed by one team. And so scalability and everything should be managed by that team and independently for that microservice. So there should not be any real dependencies between the scalability of one service and the other services. And we had drawn this like 5 years ago, 2011, 2010. We did our first take on building a microservice architecture, but it didn't really work out all that well because we ran into reality. We drew it like microservices and own scalability, but then we came and said, this is what we do, but this is what we did in our data centers. Each delivery for each solution, for each customer, as I said, we did really customer-driven development, got 2 servers, load balancer, and a database. That's your standard infrastructure. Put your monoliths there. But we don't want to do monoliths, we want to do small things. We had kind of a lot of questions about that. Are you crazy? You want to do small things? You know what that's going to cost? I mean, if one delivery has those 2 big servers, and you need 1 server per component, you know what that's going to cost? Yeah, but they don't need to be as big. What? There is just one size of server. Yeah, but it doesn't have to. It does. Do you know what it's going to cost? No, tell me. I don't know. Nobody could really tell me what it would cost to build the microservice vision that we had. And part of the problem was that, well, this is how kind of stuff evolves that comes to infrastructure at our place. So we have architects and developers that kind of draw some kind of software architecture. Then we have infrastructure architects, which sit in another organization that say, no, you can't change the infrastructure. That's basically their role to say and what they do. They don't, or at least we have not, worked hand in hand. They have been kind of blocking evil stuff from developers into the infrastructure, has been kind of gatekeepers towards our operations organization, which kind of, they get something and they set it up with something, and then they get applications and host them on that something that they set up. And yeah, I forgot the infrastructure projects as well. Once there is something new that needs to roll out, there's an infrastructure project which kind of gets the don't change any directive from the architects, and then they deliver something to the operations guys. And then there's a cost to it, and the cost is just known by somebody who sits in a financial department, and he has some kind of weird formula, leasing cost or write-offs or whatever, and divided on who uses it, and this is what it costs. Nobody understands it, but it's expensive. And people tell people that it's expensive, and I actually don't know if it was expensive before, but it's just what I've heard. So what options did we have in the past to do it? We had the worst option, which was the one we actually did, to basically just take everything and co-deploy it on the same server, because that was the easiest thing. So we took like something that was built as microservices and just squeezed it all onto one server. Actually, even worse at that time in the same JBoss. Definitely not independent life cycles for everything. Everything depends on each other, and it's bad. Changing Java version affects everybody, and so you get no benefits of doing microservices, and you get all the and you don't get any benefits from doing a monolith either, because there are a few, but you don't get that either. It's just worst of two worlds. Then we talked a little bit about doing, for our next generation, next take, we talked about doing containers, Docker. It's kind of nice, especially since we had a lot of infrastructure sitting in-house, but problem was that our infrastructure was kind of old. It was like RHEL 5 and early RHEL 6s, so we couldn't actually run Docker on it. And we would need to reinstall OSs on all these old servers, which we couldn't really do because we didn't have the manpower to do it, because they were all manually managed. So then it would require us to buy new hardware in order to host the microservices on, and then we would be forced to do resource planning. I would be getting questions about how many servers will we need, because even if we do Docker and do small containers, then, I mean, it will fill up. And once it fills up, how do you scale out? I mean, am I the one who causes the need for another server? Do I have to kind of do all the resource drive the purchasing of a new server, or who does that? And it's a horrible process to do in-house for us, the purchasing of the server. So we didn't really want to do that. I think Docker is really nice for portability, but I'm not a fan of the co-deploy stuff on the same servers. Sure, if you have 3-year or 5-year leases on your hardware and you still want to use it, I maybe consider it. But it's also hard with all the wiring that you need to do with Docker. And I didn't like it. So we actually decided to move to Amazon. And there we can do what we want. We can just build things with load balancers and scaling groups, and have everything launch as one of its own stack. We can we can do, service discovery on without load balancers and DNSs, and we have options to do everything we want, and we can scale it independently. So that's what we decided to do, and I mean, we can do everything we want, so how hard can that be? Well, the problem with that is that you get more worries and more costs within the organization, because what will it cost us to move to Amazon? How does auto-scaling affect us? How many servers will we need? And I don't know how many hours I spent in meetings where we were actually discussing how many servers in Amazon will we need for the next year. And resource planning for the cloud, resource planning is culture, it's DNA. It doesn't go away just because you move into the cloud. And there are some really nice things about auto-scaling, but there's some really scary things as well. I mean, you can write a really crappy application, and as long as it sort of scales horizontally, then you get away with it. But you just throw iron on the problem, and well, it's nice for a short while, but until you solve your issues and can scale down again. But it really is a problem that you can scale out, and you don't really have. You need to have good quality control and good measurables around actually how much you're using. And you have the instance sizes as well. That's another dimension. You can, you abuse your memory. Well, just put the bigger instance with more memory in there, and you're kind of going to be okay. But all that drives cost. And the vision we had was that, one team should manage the life cycle of a microservice, which means that the one team should be the one team that actually decides how much is it allowed to scale, what should the size of the instances be. And that should be the job of the DevOps team. But in the past, it's not been like that. Developers are not allowed to change infrastructure. So we had a little bit issues with this and discussed it a lot, because this is what kind of happened with our infrastructure change process when we started moving towards Amazon. Well, the architects and developers, they actually do what they're planned to do and just get it done. Infrastructure architects kind of were frustrated because they were kind of bypassed. The infrastructure projects and the infrastructure project managers were kind of pissed because they didn't even exist anymore. And the operation organization kind of confused about that we want to do DevOps, but we've been handing off stuff to them, but what happens now? That actually just last week got announced that got solved by us actually finally merging our operations and development organizations into one and removing operations, which is, this is one of the nice things about working at the old enterprise company. If you're persistent enough and work upstream for like 6 years, when this happens, it feels so good. And it actually happened, so it's kind of nice. So what we had to do was to actually redefine how we view the responsibility of the DevOps team. The DevOps team should deliver the right service at the right cost and be responsible for it in runtime. And the right cost is kind of interesting because you could always do something in a cheap way. Having individual servers for each microservice can be a scenario of over-provisioning, and you could squeeze 2 onto the same server and utilize stuff better. But right cost to me is functional and non-functional requirements. And for us, the independent lifecycle is a strong non-functional requirement. And if that drives cost, then it's okay. But we should do it at the right cost. We should not do it more expensive than it has to be. And it's the responsibility of the DevOps team to actually ensure that what they deliver is at the right cost. One thing that I'm going to sidetrack to a little bit and talk a little bit about AVS AWS has tagging of stuff. Basically, every resource you create in Amazon, you can tag with your key value, you tag it with whatever you want. And it's super important when you launch tons of servers to have them tagged with, I mean, you index them up, who they belong to, what they're for, and stuff like that. And for us, we have this scenario. We have customer-specific, and we have shared infrastructure. So we build stuff and launch stuff into networks and infrastructure specific for a customer. So it can be for customer A, for customer B, or it could be for the shared environment. And then it needs to be tagged with that this is launched for this customer, and it's launched by a specific team. So our DevOps team owns the service, so it's tagged with them as the owner and with the customer as the tenant, and then we tag it a little bit with component name and version of component and a little bit more. But it's really important because this tagging fits our business model, it fits our rollout model, and it allows us to track the cost of all the resources from the views we want to have on the cost. We also have a environment naming convention, which is important to us, so that we define environments by 4 variables, basically, and it's basically it's the account, which is our AWS account, then it's the region, and then it's the solution, which basically combination of solution and environment translates down towards VPCs in Amazon. But this is our kind of generic definition, because if you have that, you can do a lot of convention on naming of stuff and resources, and need less configuration. And you can also view your costs based on those. So what happens when we check something into our delivery engine is that there is a delivery engine YML. It's basically the YML file that says that the delivery engine should be tracking this Git repository. And so when something is pushed into this repository, we look at that file, we look at which team is set as the owner, and there's some rules for the owner. We do our tagging of their resources as the owner, but we also control rights, who gets to launch stuff and who gets to destroy stuff. So you need to be member of the owner group in AWS in order to be allowed to manipulate something that is set as being owned by this team. And we build it with our build pipe, and then once it's built and tested and baked into AMIs, it's launched as a auto-scaling group with load balancing, some DNS names, some alarms, and there's a whole stack of things around the service that we throw out at the other end. And all the resources here are tagged with the team, with the customer that is for, and that way we can track the cost, which is nice. AWS has a tool, they call it Cost Analyzer. It's okay, but there's problems with it. I mean, one of the biggest problems is that AWS does great services but horrible UIs. And it's also kind of hidden in the console. You need special rights to access it, and it's kind of far away from my application that is launched. So even if I see a trend here, I put the tags in. I don't really see what is it that I'm paying for. What is this curve for? And so it was kind of hard. And we had the situation where we're getting traction moving into AWS, and the questions, how much does it cost? Have they thought about cost? And people start calling more and more meetings around cost. And in our team, we have one important strategy that's made us really efficient, and it's kill discussions by coding it. And so we got a lot of discussions about cost, and should I teach people how to use the cost analyzer, it's going to take a lot of time. It's going to be a lot of more meetings, and I don't want to do that. So, of course, there has to be an API for the Cost Explorer. But no, for some reason, AVS does not have an API for that. They usually have APIs for everything, but not for the cost analyzer. But they do a nice thing. They put on a almost hourly basis, they update a cost report for you in a S3 bucket. So we basically took that file, put a Lambda that listens on it, put it into a database and built a API on top of it ourselves. 3 man-weeks to do that. So it's not a big investment to do that. And it was wonderful because kind of annoyed that I don't have it on the screen. Yeah, a few things about AVS and cost before we move on. You have the infrastructure as a service, low-level services. There you pay basically per started hour. It's your Postgres, Oracle databases, your Linux instances. For those you pay per started hour and depending on size and storage. And as you move towards bigger instances and more storage, there is a hockey stick to your to the cost. So, and especially as you move on the storage towards there. But if you use the high-level services like DynamoDB or S3 or Lambdas, Lambdas, I love them. They're awesome. It's one of the best things they've done. And DynamoDB is great as well. But there the cost is linear. You pay basically for, you say I want this amount of requests and you pay for that, and it's quite a linear curve. I've not really looked at it if it's a hockey stick, but it's much more linear, and there you pay for the Lambdas, you pay for every 100 milliseconds of CPU time you pay for. You in Dynamo, it's very much read-write heavy. There's a little bit storage in it as well, but it's basically read-write provisioning, and same for S3. But so what we did our bookkeeper service, and we put it into our continuous delivery GUI. This page is basically our versions log of one component. So here you see that this component is 3 version changes. They're launched into different environments. You see that it's launched into pre-prod, into QA. There's a little bit strange namings going on here, but so you see they're launched in these environments, and this is the cost over time, and the colors correspond to the different environments. So you basically see that this component has this cost in all the environments that it's launched in, and it kind of, yeah, you saw it dropped off there. Reason November 1st we launched this service, so we had just test data in there from the beginning. So from November we started collecting the data, then we launched it for the teams around late November. They started seeing the cost and drastically reduced it because they kind of, if you have a curve, you can reduce it. It's a good thing. It's quite easy to do. You just adjust your instance sizes and relaunch your application, and you pay less. You see it the next day that your curve has gone down. Really easy. We also, on the same view, if you expand the environment, we display usage of the service. This is actually quite old snapshot. This is from when we just had CPU load. We have requests with like 10 different metrics we show there. So you can see here, this one is running on 6 servers, and it's kind of low CPU utilization, so that one is definitely over-provisioned. Should be decreased the instance size or decrease the minimum of servers needed, and the cost will drop for this one. So now we're kind of seeing actually what we're paying for, and bring it to the view that actually the teams are working with. But we also have the other view. We have the team owners that are responsible for the entire team and for actually carrying the cost. So for them, you can view like a full view for that team. So here it's grouped by owner and by components. You basically see all the applications owned by that team and what they cost collectively, some trending there. And this view can also be used if you go from a customer. So you search by not owner, but by solution, and you enter a solution and you see what the infrastructure cost for that solution is. And from there you can click into the build pipes and stuff like that on the links here. So it gives the different stakeholders, the solution owners, you have the team owners, and you have the team members. They each have their view of the cost that makes sense to them and is close to what's actually being built. So now we can actually do what our vision was. We can actually build microservices, launch them in AVS with life cycle of its own, and actually know what it costs. And when I get all these annoying questions about what does it cost, what does it affect us, if we launch another service, what will it cost? Just go look at the graphs. And if somebody comes to me like, okay, so we're launching this new service here, what do you think it will cost? Well, what does it remind you of? Is it the same characteristics as this service or as this service? Look at their cost and predict your own through looking at their metrics. And we actually removed all those resource planning meetings and discussions, and now we can actually just look at metrics for cost and know and do our predicaments from there, which has saved us not just time but headache, because I hate those meetings. It's frustrating and boring. So no more capacity planning, which is super nice. Yeah, and the thing about DevOps, and I mean, as I said earlier, most developers hate cost. I mean, if I ask you what does it cost, then you kind of, I don't know, you shy away because you don't want to make commitments on stuff as a developer that you can't really affect and that you have not seen specifications on. But if you give it to, if you enable the developers to actually see this stuff and know what they're working with, then they can commit. And most developers are actually responsible. And if you have DevOps teams, then you definitely have enough responsible people in the teams so we can trust them. And that's basically the nice side of DevOps for me, is that you actually trust and empower the team and the individuals instead of doing old school committees which kind of build distrust throughout the organization. We still have way too many committees that are there just because we don't trust people, but we're heading in the right directions. What I'd like to do someday is, I mean, in our pipe here, we do load tests as part of our build pipes. We can do them on each commit, or we can start them manually. But I want to combine cost and load tests. I want there to be a price tag on the load test execution. This load test costs this much, and this load test costs this much, and then you can correlate your performance between the two different versions and see if is the performance still stable? Yeah, but the cost is driving up. Then it's kind of okay, but you have some issue because you need more scale to deliver same performance. Maybe that your performance is going up, but it's at a huge cost. Somehow you want to have this. You want performance and cost to go hand in hand. And someday I want to be able to include that in our continuous delivery as a service. Problem with that is a little bit the cost model of AVS, the hourly rates. It's kind of chunky and heavy. It's not fine-grained enough when you do load tests, because these load tests, you want to do them more as benchmarks. And in order to get a benchmark where your cost is based on an hourly rate, then you need to run it for quite a long time. But whenever we move, if we ever move into doing Lambdas and DynamoDBs in our production environment for our end user services as well, then we can start doing that, because those services have the capability of delivering fine-grained cost reports. I think that would be nice, because I mean that's one of the reasons why we do performance enhancements, because we want to optimize our application to consume less resources. We talk about load tests in mostly in order to handle our expected loads, but it's basically just because we don't really want to see and can see the cost. But I think it's equally important to deliver at the right cost as it is to meet the requirements. So that was all for me. I have a blog that I sometimes write about stuff that's about continuous delivery. You can reach me at either my Gmail or my work mail at Wireless Car, or at Twitter on that handle there. Yeah. Any questions? Yes.
What about open sourcing? It would be very interesting to have.
Yeah, I actually thought about it, because the bookkeeper could be open sourced, but it's, as it is written now, it's quite heavily around the tagging strategy that we have. Open sourcing it would be require it to be more dynamic towards custom tagging strategies, but I think that would be doable. Or AWS could just do a cost analyzer API. I think they will eventually. Anyone else? No? Go and drink beer then.